By the way, topic 5 is all about integration with limits, or definite integration, definite integrals. Yesterday's multiple choice 4 was all indefinite integrals. That's why almost all of them had a plus C at the end. Today is really similar stuff, but they all have top and bottom limits. So it's that one extra step of plug in the top minus plug in the bottom. That part I'm not worried about. That part's not that much extra. What is different is some of the concept stuff. So how do you find the area under a curve? Yeah, that's right. Well, it must be an integral it must be a definite integral from a to b of f of x dx. So this is also some of the applications where we use definite integrals. How about the average value of a function? You remember how to find that? It involves the area. Yes, no? So the average value is that area divided by the width. Average value is 1 over b minus a times the area. And the MVT for integrals says that C is between A and B. Right. Mean value theorem for derivatives has kind of that same conclusion. C is between A and B. But for derivatives, it's calculus slope equals algebra slope. For integrals, it has to do with average value. Right, how about the integral from a to b of f prime of x? So the antiderivative of the derivative. So this isn't hard. This is just, are you paying attention? What's the antiderivative of the derivative? Not capital F. If this, yeah, it's just f. If this was just a lowercase f, then our answer would be capital F. F of b minus f of a. And then the other way, the derivative of the integral from a to x of f of t dt. The derivative of the integral. That's just f of x. Do you know why it's not f of x minus f of a? I mean, it's not, but do you know why it's not? Because it's a constant, and what about it being a constant makes it go away? What's the derivative of a constant? Zero. One more line, and maybe this will further remind us why it's not there. The derivative of the integral, So already we're thinking, wait a minute, those cancel each other out from a to u of f of t dt. What's that one going to be? Pretty similar, except with that u there, there's one more thing we have to sort of account for. That we kind of didn't have to account for in this one.
Let's see. Oh, it's not in terms of
This may be something in terms of x, so you're on the right track. Like this could be a cosine of x up there, or an x cubed, or e to the x. So you plug in the top thing, whether it's e to the x or cosine of x or whatever, but then you multiply by the derivative of the top thing, so the chain rule. So du dx or u prime, however you want to phrase that. And that's why, if you want to think about plugging in the bottom one, so minus f of a dA dx, but if a is a constant, what's dA dx? 0. So that's why it wipes that part out. Now if we back up to that last one, the chain rule would be times 1, and again minus f of a times 0. So we kind of throw all that stuff away and just go with that part. Okay, so that's some of the background concept stuff that happens on the topic 5 worksheet. So the first several are just straightforward. In fact, the whole first page is. Hint on number 90. Do you remember how to handle integrals of absolute value? There was one on the test, and there was a hint on the test. Because I don't know how to do an equation antiderivative, but what else does this sign mean? What else does that symbol mean? That's what the absolute value symbols mean. What else does this symbol mean? The S. It does mean sum. It does mean antiderivative. It also means area. So I could probably work this problem as an area problem a whole lot easier than like an equation antiderivative problem. So I just want the area under the absolute value from -1 to 3. All the rest of them are equation type stuff. Midpoint, trapezoidal sum. Didn't go over those, but remember this is just add the rectangles. And this one's add the trapezoids. 93, average value. 94, 95, all of the rest of them are like concept questions. All right, so you have a few minutes to work on those, and I'll answer questions on those tomorrow.